What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to talk about the discriminant. The discriminant is part of the quadratic formula that tells us the number of solutions to a quadratic equation. Now, we also call solutions zeros, roots, x-intercepts, solutions. Those four things are all the same thing. So what we're going to do is we're going to look at that. Let's get to it. To start off with, let's look at these two versions of the quadratic formula. Remember, in my videos, I like to separate out the axis of symmetry by bringing this out here and making it into two fractions. You probably see it here, but just remember that this means that this is part of a fraction and that this piece is also part of a fraction. So you basically have combined like terms. So if you've got the same common denominator, you're combining them into one fraction. That's all that this is saying. But now, what is the actual discriminant? What do we define as the discriminant? The discriminant tells us how many solutions or zeros or x-intercepts or roots the quadratic has. And if you think about how quadratics are graphed, there's really only three different scenarios that the discriminant could be. The first thing, if we look at the first type of graph, it might be something that looks kind of like this. This is typically the first type of quadratic that we're used to seeing, where it's crossing the axis at 2 points. Another version could look something like this, where it's just touching at one spot on the x-axis. And then finally, the last version might be something that looks like this, where we have a quadratic that is really floating above the x-axis. Now, of course, we could take each one of these things and we could also do it as a negative version as well, right? We could have one there. We could have a negative where we're just touching at one spot there. Or we could even have a negative where it's floating down this way. But really, it boils down to, are you crossing the x-axis in two spots? Are you crossing it in one spot, two spots? Or are you not crossing the x-axis at all? So let's look at how we can use the discriminant to actually find that. So the discriminant is this piece inside or underneath the square root. Sometimes you'll see the discriminant written as delta, and they'll say delta is b squared minus 4ac. This is how it's written in the IB formula booklet. Let's look at these three examples, and we're going to use the discriminant to determine what are the indicators that say, we've got two solutions, we've got one solution, we've got no solutions. And to start with, we need to have this in standard form equation. And standard form is when it's written like this, and we say that the a is the value in front of the x squared, the b is the value in front of the x, and the c is the value without a variable attached to it, or the constant value. If we look at our first blue example here, we can see that a is equal to 1, b is equal to -3, and c is equal to 2. So as we drop this into the discriminant, we can see -3 squared minus 4 times a, which is 1, times c, which is 2. That's going to be 9 minus, 4 times 1 times 2, that's 8. So 9 minus 8 is going to equal 1. Now let's see what we get when we do the same thing with our middle graph, the purple graph. Here we can see that a is equal to 1, b is equal to 2, and c is equal to 1. So our discriminant here is going to tell us that we have b squared, 2 squared, minus 4 times 1 times 1. So we're going to end up with 4 minus 4, and we end up with a result of 0. Okay? And then finally, with our red equation, we have a is equal to 1, b is equal to 2, and c is equal to 4. And let's see. So the discriminant in this case is going to be b squared, 2 squared, minus 4 times a times c. So we've got 4 minus 16, or a -12. You know, we've got three very different, distinct values. So how do we kind of summarize this? And we could go through lots and lots of examples, but really what it boils down to is this. If the discriminant is greater than 0, then you are going to have two real solutions. If your discriminant is equal to 0, then you're going to have one real solution. And if your discriminant is less than 0, you're going to have no real solutions. These are the things that you need to remember. That this thing is greater than 0, whether it's equal to 0, or whether that it is less than 0. Let's take this a step further and see why these values mean these things. Why greater than 0 is equal to two solutions, equal to 0 is one solution, and less than 0 is no solutions. As we drop this back into the quadratic formula, it's going to say negative b over 2a. So we've got a negative, negative 3. So we're going to have 3 over 2a, 2 times 1. And then we're going to have plus or minus, and in this case, we already found the discriminant to be 1. So we're going to have the square root of 1 over 2. So x is equal to 3 over 2 plus or minus 1/2. And here's the real rub for why this works out the way that it does. Is that we're going to ultimately say x has got to equal 3 over 2 plus 1/2. And we have to say x equals 3 over 2 minus 1/2. So this is going to give us a solution of 4 over 2, or the value of 2. And this is going to give us a solution of 2 over 2, or the value of 1. So here are our two solutions for this equation, the two places where this thing is going to cross the x-axis. Now, if we look at the purple equation and we put it into the quadratic formula, we're going to have negative b over 2a. Negative b, negative 2 over 2 times 1. So it's going to be over 2 plus or minus the square root. Again, we already found it to be 0 over 2 again. So x is going to equal negative 1 plus or minus. Well, the square root of 0 is 0. And 0 divided by anything is 0, so we're adding it plus or minus 0. Well, of course, we're not going to take negative 1 plus 0 and negative 1 minus 0 because it's the same thing. So we just end up with negative x equals negative 1. There is our one solution for this quadratic. And now we go with our red equation. So we're going to take x equals negative b, so negative 2 over 2a, 2 times 1. Forgot the negative there. And we're going to add or subtract the square root of negative 12. So we're going to have negative 12 over 2 as well. Now, what is the square root of a negative number? It's not possible. We can't take the square root of a negative number. No two numbers multiplied by themselves are going to give you a negative number. You could take a negative 2 times a positive 2, but that's not times itself. That's times a negative times a positive. So it's impossible for this to happen. Now, this says no real solutions because there are actually imaginary solutions that you can find with this. The imaginary number is I, which is the square root of negative 1. That's used in higher level mathematics and physics and electronics, but not in the standard level course. So since this piece is not possible, it's not a real answer, it's not in our real number system, it's only in the imaginary number system, this is not possible. And since we can't do that, we can't add or subtract a negative 1 to something that's impossible for us to do in the real number system. That's why this thing is called no real solutions. That's really why we have the three different distinctions. The two real solutions, the one real solution. Again, I'm doing that thing again. The one real solution, the two real solutions, and no real solutions. So what happens if we want to look at a slightly more complicated question that you might see on an IB exam, where we've got these things that are constants that are representing A and B, but they're not, we don't know what they are. And we want to find out how many solutions this function can have. What are the boundaries to create no solutions, one solution, or two solutions? And we're going to get to that in the next video, after you give me a thumbs up if this video has been helpful for you, and also after you work this through or try your best, see if you can figure out what would happen with this, and then we'll check our solutions in the next video. I'll see you there.